Hello everyone, how's it going? My name is Dan the Tutor. In this video, this is the second part of a two-part video on telling if sequences converge or diverge. In the last video, we talked about the rule for how to tell if they converge or diverge, which is simply take the limit as n goes to infinity of your sequence. You will either get infinity or dne, which means that your series diverges, or you'll get not infinity or dne, which means your sequence converges. And now we're just going to look at a bunch of examples today. And for the examples we look at, I encourage you to try them on your own first, and then only watch the video if you want to see the solutions or if you got stuck. So without further ado, here we go. Here's the first one. The sequence is a sub n equals 1 minus 2n over 3 plus 4n. Go ahead, give it a try. Okay, and here's the solution. So first take the limit as n goes to infinity of 1 minus 2n over 3 plus 4n. I see that these are polynomials where the degrees are equal, which means that the result of this limit at infinity is just going to be negative 2 over 4, which is negative 1/2, which is not infinity or dne, it's just negative 1/2. So this converges. And fun fact, if this was a series, this would diverge, but we're not there yet. This is still sequences. Okay, next one, I have a sub n equals 3n plus 3 over 1 minus root n. Go ahead, give this one a try now. Okay, so here's the solution. Take the limit as n goes to infinity, 3n plus 3 over 1 minus root n. There's a couple ways you can solve this. One way is by doing a L'Hopital's rule, which will work. But I'm going to do another strategy. I'm going to multiply the numerator and denominator by 1 over n on the top and bottom, because in the numerator that will just leave me with 3 plus 3 over n, and the denominator is 1 over n minus root n over n cancels to 1 over root n. And remember, this was still my limit as n goes to infinity. Wherever there's an n in the denominator, that will become 0. In other words, 1 over infinity becomes 0. That's what I'm saying. So it will be 3 plus 0 divided by 0 minus 0. In other words, 3 over 0. This limit does not exist, or you could say it goes to infinity. Either way, this limit and this sequence is going to diverge. That's it for the second one. Here's the third one. A sub n equals the cosine of n pi. A little hint I'll give you before you start it. Finding the limit for this one at infinity is very difficult because it's the cosine function. It goes on forever in an oscillating pattern. So another strategy you can do is you can list out the first few terms of the sequence and figure out what we're converging to. So go ahead, give it a try. And here is the solution. So as I was saying, if you list out the first few terms, when n equals 1, cosine of pi is negative 1. Next term is 2 pi, cosine of 2 pi is positive 1. Then 3 pi, which is negative 1, then positive 1. And as you can see, this pattern is going to continue forever. And because we're going back and forth between negative 1 and positive 1, and we're not settling on a single number, we would say that this limit does not exist, and the final answer is diverges. And that's going to be the answer for this one. And if some of you think that the answer is 0 because you watched that one number file video, no, you are wrong. Every college professor and high school teacher will say this diverges, so you should too. Next up, number 4, I have a sub n equals negative 1/2 to the nth power. And when you're ready to see the solution, unpause the video. So, the secret for this one, if you try a limit as n goes to infinity of negative 1/2 to the n. First of all, the negative part never matters for sequences, so I'm just going to ignore that. And so therefore, I really just have n goes to infinity of 1/2 to the n. Remember that 1/2 to the n can really be broken up like 1 to the n divided by 2 to the n. And the reason why that's helpful is because 1 to the infinity is going to be 1, and then 2 to the infinity is going to be infinity. And 1 divided by infinity is 0, which means this sequence converges. And just another tip for you in general for this one, if you ever have a fraction to the power of n, then the result's always the same. If that fraction is less than or equal to 1, we are going to converge. And if we are greater than 1 for the fraction, we will diverge. And that's a little shortcut for you. And then the last one I have for today, the sequence is the natural log of n minus the natural log of n plus 1. And again, just a little hint for you. If you try the limit as n goes to infinity, you're going to get natural log of infinity minus natural log of infinity, which is kind of tough to deal with. You can't just say infinity minus infinity equals 0. That's not allowed. So my hint to you is to combine these two logarithms using properties of logarithms. So go ahead, give this one a try, and here's the solution. So first, how do I combine these two logarithms? Because it's minus, it's really division, so it's natural log of n over n plus 1, and I need to take the limit of this. Now, I don't know if you know this, but you can actually reorder a limit and a natural log. So really, I have the natural log of the limit as n goes to infinity of n over n plus 1. This is allowed. And then I know this limit because it's two polynomials. Both of them have the same degree. This limit is going to be 1. So I really just have the natural log of 1 as a result, which is 0, which means this sequence converges. And that's it for that one. So that's all the problems I have today. Thank you all for watching. If you have any questions, please post them in the comments below. And I will see you in the next video. Take care and bye-bye.